Hi everybody, we're doing a video today on the idea of reflection, but to start us off, let's do a little bit of a recap of ray diagrams and thinking about the mistakes that get made in these. So there are 4 different images on the page. Have a look through now. Can you spot the mistake that has been made with these different images? And I'm going to give you a second to think about that. So with image A, the main mistake here is that the arrow is pointing the wrong way. Our eyes do not project light beams. The light is coming from the candle, so it should be pointing the other way. With the image of the wood, it looks here as if the light rays are bending around the wood, and we know that light moves in straight lines. So what would actually happen here is it would hit the wood and it would not pass through the other side. Hopefully the shadow one was a little bit easier to spot. The shadow's reversed. It's this arm that's out here, so the arm should be out on this side here too. And lastly, with the glass, we can see here again the arrow is pointing the wrong way. This one was correct, this one was not. So it should be going all the way through towards the eye. Here are some more, so I'll give you a few more seconds to look at these ones. So with image E, the issue here is that the light cannot pass through wood because it is opaque, so there would be no light ray coming through the other side. With F, this is what we're going to be looking at today. This is reflection, but again, the arrow is pointing the right way. It should always be pointing towards the eye. With G, the shadow is going the wrong way. If the light is here, it would hit the wood and therefore form a shadow in this direction over here. So it should all be going that way. And lastly, with H, light does not bend. So this light ray coming down here would continue to travel this way down here. And this light ray here would continue to travel that way there. They wouldn't bend round the corner. So what we're going to look at today is reflection. And everything can reflect light in all directions, well, most things. And nice plain mirrors give us nice reflections we can see images in, whereas other surfaces can be quite bumpy, and that's going to spread the light in all different directions, so it scatters the light unevenly. Usually at this point we'd do a practical here and we'd start looking at reflection, but instead today I've sent you a video link that hopefully you've watched before you have watched this video to explain how to do the practical. But what we'd be looking at here is measuring 2 important angles, the angle of incidence and the angle of reflection. So the incident angle comes from the incident ray, and this ray here would be the incident ray because it's coming from the light source. Okay, so in here there would be a light bulb that we would use to create the light. Now that would hit the mirror and it would then reflect off of the mirror, and that would then be the reflected ray. This one over here is the reflected ray. So this angle that you'd measure between here and what we call the normal, so the normal is just a line that's at 90 degrees to the mirror. You'd measure that angle in there, and then you'd measure the reflected angle as well. And what you would hopefully find when you did this practical was that the angle of incidence was equal to the angle of reflection. So the 2 of these angles would end up being the same. So if our incident ray had an angle of 30 degrees, then the reflected ray would also have an angle of 30 degrees. Remember, the normal is just an imaginary line that we've drawn on just to allow us to measure those angles to the middle. key point here is remembering how to use a protractor. So you're going to come on to doing a worksheet shortly, and that worksheet is going to require you to make sure you measure angles. So you need to use a protractor. Remember how to measure using a protractor. Make sure that that line that you're starting with goes on the black line on your protractor and stops at that middle point there. And there are two scales on your protractors usually. There's normally one here that starts at 0 and the other one starts at 0 on the other side. You're always going to start from 0 and measure around. Okay, if you're measuring from a big number to a small number, then you're going the wrong way. All right, so small number to big number. So you can measure that angle like that. Okay, so this would be your normal line that you'd measure along here, and that would be your angle coming in that you're trying to measure. Okay, these ones obviously are wrong down here. Don't measure it like that. So let's just go through how we would do this. So you would have your line. Now sometimes what they show is they put these little lines on the other side, shows kind of like the back of the mirror if you like. And you would then, using a ruler, you would have your normal line going straight up. That was a bit wonky, but you get the idea. So then we'll call that the normal. And this is the mirror. Okay, so your ray would be coming in at that point there. Okay, that is labelled up as your incident ray. You would measure this angle here. Okay, I always give that little symbol there to show that that's my angle of incidence. Once you've worked that out, and this is what you're going to be looking at on the worksheet, whatever that angle of incidence is, it must equal the angle of reflection. So you would take your protractor, you'd measure this, let's say that worked out to be 45 degrees. You'd measure an angle this side to 45 degrees, mark that point on, and then you would just take your ruler and join this point and this point together and extend your line up, although not quite like that. There we go. And then pop your arrow on to show it coming off of the mirror towards wherever it's going towards, and that is your reflected ray. And this in here would be your angle of reflection. So the two of them must be exactly the same each time. So this is the worksheet you're going to do. So you're just going to do it exactly like I did. Each time you're going to want to measure your angle. So draw in your normal. This is really hard to do on a screen. Okay, measure that angle there. Find out what that angle is. Then measure around, make sure the angle's the same on the other side. Join that center point up to that middle point there. And repeat for each of these. So your normal here will be down here. Your normal on this one as well will be down here. This one's at an angle, the mirror here. So you'd need to make sure that your normal is at 90 degrees each time to the mirror surface. This one, I'm going to let you think about that one. Would we get a reflected ray? Where would it be? And this one here, this is a rough surface. So remember, light gets scattered here. So we're going to have rays going in all directions. So just thinking a little bit about application of mirrors. Ambulances, for example, I'm sure you've seen them before, where they have it written the wrong way on it. And that's obviously because in mirrors we see a mirror image. So when you're looking in a rear view mirror in a car and an ambulance is behind you, you'll be able to see the words ambulance. And that's just because in mirrors we see an image. So if we had a cake, for example, it's probably not the best topic for me to talk about right now because I'm quite hungry. But the image light from the image would go onto, the light from the object would go onto the mirror. It would reflect off of the mirror and into the eye. But what the eye sees is the image in the mirror. So the eye doesn't realise that that light source is coming from over here. It thinks it's coming from in here. So if you take those lines back to the point where they be joined together, that's where the eye is going to be thinking the object is. So your eye sees the image, not the actual object itself. That's quite a tricky thing to get your head around, and that's kind of taking you up to the higher levels that you'll need to start thinking about later on at GCSE. And the last little thing is just thinking about how can the fox see the rabbit. So these are periscopes. Usually as well, I'd get you to have a chance at making these. There are videos and websites online that show you how to make periscopes at home, but they are quite tricky. They involve quite a lot of kind of sticking, finding something with a mirrored surface. Some people suggest using old CDs as the mirrored surface. They're quite hard to do. You can look up some ideas if you want to give it a go, but do always make sure you get permission, whoever's looking after you at home. So the idea behind these, of course, is the image up here. The light would come from there, it would reflect, and it would come down, and it would reflect, and it would go into the eye. Okay, and each time, although my image isn't so great because I haven't used a protractor, you'd need to make sure that the angle's the same each time. We would measure from this one here, measure here, and this angle here, and here would be the same each time. So that's everything on reflection. Make sure you take a chance to make some notes. Remember, you've got the AQA Activate textbook that you can read about this under the topic of waves as well.